Visible, sir?
Yes, it's visible. So guys, can you confirm that screen is visible and voice is clear?
Sir, actually, sir, we need to give them the rights to unmute themselves.
Okay, so they can send. Oh yeah, they can send it. They can see it and they can hear. If anyone want to talk, then you can give them access to talk.
Okay.
Guys, if you are getting the access, please keep on the unmute. Sorry, on mute, so it will not disturb other people. Yeah.
Okay, so sir, can we start?
Yes, sure.
So sir, guys, today we are going to learn about the will AI automate the data science job. So firstly, we are going to understand what is data science, what it's all about, what are the fundamentals in it. So can these fundamentals be online or not, or can these fundamentals will work by the AI or not? So let's get started. Let's firstly understand the concepts of machine learning. Why machine learning? Because machine learning is the important concept in particular data science. If data science is having a lot of processes in it, the machine learning is particular process in that particular list of processes. So I will say that this is a data science, and in the data science we have a lot of processes here, but in these processes we have one main process, that is machine learning. Okay. So what is machine learning? Machine learning is a particular model, or I can say that machine learning is a particular process by which you will train your model based on the data. Suppose I will give you the one example. Let me share my whiteboard so that I will make a clear example of what is machine learning. So machine learning means, suppose you are having the ordinary program. In the traditional way, if you want a particular thing to happen by the computer, means you are giving instructions to the computer. What you need to do, somebody's mic is on, please unmute, please unmute, please mute yourself. Okay. So in the traditional method, what we do, if we want a work from our computer, if we want computer to do some work, what we do, we mention some rules, we give some constraints, we give some instructions, and then we expect a result. So this is the traditional way. But in the machine learning way, what we do, if we want a particular problem to be solved, we just give data, that particular problem related data, to our ML model, and then we expect a result from it. So we are not defining any rules, we are not defining any constraints, we are not defining any instructions, we are directly getting the result. By how? By just passing the data. So I can make a conclusion here that in the machine learning model, I can receive the results, I can get the result by just feeding the data. Okay, so I will get the results, I will get the insights about the results by just feeding the data. Suppose I need a particular analysis of something. If I go to the traditional process, firstly I need to design the rules, then constraint, then instruction, then I will wait for the result. But if I go to the machine learning model or machine learning way, what I have to do, I just need to gather the data. A lot of data I need to gather. Then I need to feed this data to the machine learning. And then the machine learning will find the insights about that data and it will give me the result itself, without having any problem, without making any rules, without defining any constraint, without defining any instructions. So this is the traditional way and this is the machine learning way. So let's see what my definition is telling about it. The use of development of computer science that will be able to learn and adapt without following explicit instructions. In the machine learning, we are not giving any explicit instruction. By using algorithm and statistical models to analyze and draw inference from the patterns and data. How it gives us the result? It gives us the result by just, one second. So what we are doing here, we are just analyzing the patterns in data. We are analyzing the patterns in data, and by analyzing those patterns, we are getting the result. So another definition is machine learning is a method of data analysis that automates analytical model building. It is a branch of artificial science based on the idea that systems can learn from data. Means the machine learning concept is based on the idea that the machines can learn or the systems can learn from the data without giving any instructions. All we need to do is to gather data and feed this to the system and it will learn from it. How? It will apply the statistical models. Here are the statistical models and analysis to get the inferences from that data. And it does another thing, it identifies the pattern and make decisions with minimal human intervention. So the first thing, if I tell that, if I am feeding the data to my machine learning model, so if I am feeding the data to the machine learning model, what I expect in the begin in the out in the back end is happening. In the back end, I can say the patterns, inferences, or I will say that hidden insights are being checked out. Hidden insights are being checked out, and based on these things, we apply statistical and mathematical model. We apply statistical and mathematical model so that we can get the results. And all of this process is done by the machine learning only. We don't have any human intervention here. Our human intervention is till then we are feeding the data. Rest of the thing is done by the machine learning model. Okay.
Okay, so I want to add one more point, Ajay. So here, guys, did you understand how exactly the machine learning model works, or what exactly that machine learning model do? So as Ajay was explaining that basically, whenever you have any data, so we pass that data to the algorithms and we train that algorithm. Suppose there is one kid and you are training some mathematics or some basic of maths to that kid, like 2 plus 2 is equal to 4, 4 plus 2 is equal to 6, like that. So what you are doing, you are passing some data to that kid and you are telling that if this plus this is equal to this or this plus this is equal to that. So you are training that kid with the existing data. In the same way, in machine learning, what we do, we take the existing records, we take the some existing what were the data we have in the different systems. Like suppose if we take the weather forecasting, if you want to predict the what will be the tomorrow's weather, where there will be any raining, there will be any means what will the temperature, all these factors if you want to find, you will take the last 20-30 years of data, you will pass that data to the systems, system will get trained by himself, he will create his own rules. That is the beauty of machine learning. In machine learning, machines get learned by themselves. We do not write the exact logic, we do not write the exact rules that if the temperature on the last suppose 15 years, this was the temperature, this was the wind speed, this was the direction, this was the region, then that is the probability of the raining in that region. So what we did here, we have defined some data and we are just passing that data to the machine. We are not writing hard code rules like if the temperature is equal to this one, the speed of the wind is equal to this one, and the direction of the wind is equal to this one, this much cloud is present in the sky, and that then what is the probability of raining. So we are not defining, we are not writing each and every conditions one by one. You are doing only one thing, that you are taking all the data of the 15-30 years and just telling to the machine that take this data and get learned by yourself. I will not tell you that what is the conditions. I will just pass you the data and you have to learn by yourself. Afterward, whenever I will pass you the new record, you have to tell me that what is the output. You have to tell me that will there be the raining or not? Will there be, what will be the temperature in that region? On the basis of the wind speed and the temperature and the whatever the different parameters I have, on the basis of that, model has to predict that what will be the futuristic value. So this is the fundamentals of the machine learning. Okay, so just I want to add that one. If anyone has any confusion in this point, they can put in the chat message and they can raise their hand. We can unmute them. Is it clear?
No. Okay.
Okay. What about other people? Lots of people are there in this session. More than 65 people are there.
Okay, it's not clear. Okay, sir. Let me.
It's they're saying it's clear. It's clear or not clear?
Clear.
What about other people? Ravi, Pranav, guys, make it interactive. We don't want to just do one round of one way of communication. So you should understand this thing. This is not just one way of communication that I'm just talking or Ajay just talking. You have to put your thoughts. You can put your questions. You can put if you're understanding or not. So you will get more in that. So keep it communicative. Okay. Yeah. Okay. So I think guys is understand. So yeah, Ajay, you can move it. Thanks, Ajay. Thank you.
Okay. Thank you so much, sir, for the extra point. So we have now 7 steps of machine learning. As I said, and also Saurabh sir discussed that we are training the model based on the data. So there should be some steps regarding this data and this training. So what we are doing here, we have 7 steps of machine learning. In the 7 steps of machine learning, the first step is the gathering data. Because the machine learning is wholly and solely dependent on data. Suppose this is my machine learning model, this is my ML model, and all it needs is data. So if we don't have data, will it be trained? Will it learn anything? No, it will not learn anything. So our first step in the machine learning is to gather the data. Gathering the data means that regarding that problem, suppose my problem right now is to predict whether tomorrow it will be raining or it will be sunny. So I will gather the data, previous history data means yesterday's data, day before yesterday's data, previous week data, previous month data, previous year data, and previous year's data about the weather. So I will gather all the previous weather data and I will complete my first step. I will complete my first step. Now I gathered all my data. Now I reach to the step 2. In the step 2, it's known as preparing that data. Preparing that data means that I got the data, I stored it in my local memory, suppose my storage, but my hard disk, my servers, I stored this data now. Now I need to prepare this data. Preparing the data means that sometimes while gathering the data, there are some problems in it. Some missing values get generated, some additional values get generated, some columns are in the data which are not necessary to be taken. Suppose we are gathering the weather data and we are getting some data which is not necessary to predict the weather. So we need to remove them. Sometimes we are getting the data in different formats. We need to convert them to the format machine learning can understand. Suppose right now machine learning can understand only CSV files, .csv file, and we are getting our data in JSON format. Okay, we are getting our data into a JSON format. So before giving this to the machine learning model, we need to convert this. We need to convert this from JSON data to the CSV data. So these kinds of problems can arise. Suppose I will pass the preparing the data method means I am going to gather the data and I will directly feed this to the model without checking any problems in it. So it is definitely going to give me an error. Because while gathering the data, we can gather it from multiple sources. We can gather the data from internet. We can gather the data from sensors. We can gather the data from people. So a lot of sources are there and there are high chances of error in it. So without removing those errors or without converting that data to the proper format, we cannot train our model. So this is our step 2. Now in the step 3, now our data is ready. It's clean data. It's in .csv format. Now we can train our machine learning model. Now we can train our machine learning model based on this prepared data. Now I can tell my machine learning model that this is the history data regarding a particular problem. This is the history data regarding a particular problem and you need to train from it. But before that, there is the step 3. Step 3 means choosing a model. If we talk about machine learning, we have different of models present in it. Different of models like, I will write here ML. Here I will write supervised learning. Here I will write unsupervised learning. Here I would write linear regression, logistic regression, SVM, decision tree, random forest, a KNN. Here I will write DB scan, K means. Here I will write hierarchical clustering. So lot of machine learning models are available here. So in the step 3, I need to check based on the data which algorithm will be suited here. Based on the data and based on the problem, and data, we need to decide which algorithm should we pick, whether it will be linear regression, logistic regression, decision tree, or DB scan, K-means, hierarchical clustering, can be anything. But we need to take this decision based on the problem and the data. Let's get back. So this is our model 3. Sorry, step 3. In the step 4, we have the training phase. Training phase is, suppose now we choose our machine learning model. Suppose, example I will take, we chose our machine learning model as SVM. Now SVM is our prime model. Now SVM needs data to train, from where we will get the data from the step 2. We prepared our data. Firstly, we gathered the data. That data has problems. Then we remove those problems. In which step? In step 2. What was the step 2? Prepare the data. Now this is our data. Clean data I will write. Now my SVM will learn from the history data. Means suppose if the humidity is high, if it's cloudy, if it's drizzling, then it's rain, so these kind of things the SVM will try to understand when it's rain and when it's not rain. Okay, when it's rain, and it will give us the model object. Now this model's job is to predict. But before that, we are going to check the accuracy of this model. Accuracy of this model is checked in the step 5. That is known as evaluation phase. What does evaluation phase means? Evaluation phase means, suppose we are going to take one example just like the Saurabh sir take. Suppose we are taking a 4-year-old kid. For the 4-year-old kid, we are giving him the books and the teacher. For the whole year, we are teaching this kid. For the whole year, we are teaching this particular kid. Then at the end of the year, it will be an examination day. In the examination way, suppose this kid is getting only 55%. This kid is getting only 55%. And the passing percentage is 90%. And the passing percentage is 90%. Then what will happen? You will go back. You will make some changes in the book. You will make some changes in the teacher's teaching. Then you will teach him again for 1 year. Then suppose in next year, the examination, he is getting the 70%. Again, you will go back. You will make some changes in the book so that he can understand very well. You can make some changes in the teacher so that he can understand a little bit more clearly. Then you are again training that particular kid. Now he is getting the 85%, but still the mark is 90%. Again, you are going back. Again, you are going back. You are making some changes, more changes into the book. And then you are making changes into the teacher also. Then again, you are training your kid for 1 year. Now it's getting the 91%. Now it's acceptable. Now he is ready to move on to the next class. So this is the evaluation and hyperparameter tuning works. I will give you one example. Let me clear this. This is the data, and you are feeding this data to the ML model. Okay. Now ML model is training itself. Now ML model is training. This is the training. After the training, you are evaluating it. Evaluating means checking accuracy. Evaluating means checking accuracy. After evaluating, you are using the hyperparameter technique. Then again, you are going to the ML model. What you are doing here, you are training your machine learning model, then you are checking the accuracy. If the accuracy is not good, then you are again changing some parameters. Some parameters, I gave you example just now, books and teacher. You are making some changes here, and then you are again training your model. Again, you are checking the accuracy. Again, you are making some change in the hyperparameter tuning. Again, you are going back to the model. Again, you are training the model. So same thing will go continuously till then. Till then, our accuracy will reach acceptable level. Till then, our accuracy will reach to the acceptable level. When our accuracy will reach to the acceptable level, we will move out. And we will reach to the seventh step. And that is prediction. Now my model is ready to predict the outcome. What will be tomorrow? Will tomorrow be rain, sunny, cloudy, or warm day? What it will be tomorrow? Now my model is ready. So we learned about 7 steps. In the 7th step, we learn about the gathering data, preparing the data, then choosing a model, then training a particular model, then evaluation, then hyperparameter tuning, and at the end prediction. Any confusion in these 7 steps? Anyone? Guys, we are waiting for your answer. Please answer it. Do you understand? If you have any confusion in any step, let me know, please. Okay, great. Now, what is AutoML? AutoML is tied with producing machine learning solutions for the data scientist. That means if this is a data science, I will give you one example. If this is the data science, in the data science, we have long list. In this list, we have one particular thing, that is ML model. And then the list goes on. How to calculate the right data? Ravi, we don't calculate the right data. We get the data, then we make it right. We get the data based on the problem. Suppose, Ravi, right now I am predicting about the weather. I will get the data regarding the regarding the weather, whatever I will get from online. So I will get some data regarding the weather online or from some sensors. Then it's my job, it's a data scientist job to make it right, to make it feasibly, to make it usable from the machine learning algorithm, to make it clear for the machine learning algorithm so that it can learn. I will give you one example. Suppose you are having a 4-year-old kid. Will a step-by-step book will work for him, or a directly higher maths will work for him? Which one will work, Ravi? So let me unmute you. Yes, Ravi, you are allowed to talk. You can unmute. Okay. Another example. So apart from the kid, you want me to take another example? Or apart from the weather, you want me to take another example? We go for step by step. Exactly. So we go for step by step. So we got the data. Now it's our job to present it in which way? To present it in step by step way, or to present it in that way the kid will not understand. Same thing we are doing with the machine. We got the data. Now it's our job. Now it's a data scientist's job to produce it or to transform this data in such a way that the ML algorithm can learn from it. Because the ML algorithm is naive, he has not learned anything before. This is the new thing he is learning. So a step-by-step process will be good. Clear? So this is the data science. In the data science, we have a lot of processes. No issues, Ravi. So in the data science, we have a lot of processes, and in that process, our one process is machine learning model. So this process will be automated by AutoML. This process will be automated by AutoML. So what we are doing here, neither we need here unlimited queries, okay? Neither we need data model selection, neither we need hyperparameter tuning, neither we need model compression parameters. Earlier, if we saw that we need to train, we need to choose our model. It's us who need to choose our model. It's we who need to train our model. It's we who need to test our model accuracy. It's we who made changes in the hyperparameters. I hope you remember that circle. Training, evaluation, hyperparameter tuning. Training, evaluation, hyperparameter tuning. So we were continuously doing that. And was our job to choose a machine learning model. But with the AutoML, model selection, hyperparameter tuning, and model compression will be done itself. We don't have to do anything. We don't have to do anything. So this job will be done by the AutoML itself. And some of the data preparation, or I will say that some of the data clearing or data cleansing will also be done by the AutoML. Don't you feel that this is helpful? Is it helpful or not? We just saw 7 steps and we just saw how iteratable they are. Means we need to continuously do a particular process, then only we will get the answer. But here, with this, we are not restricted to use certain followings. The AutoML will do the job for us. Means some queries on the data preparation, model selection, it will do itself. Hyperparameter tuning, it will do itself. Model compression parameters, it will do itself. So now, is it helpful or not? It is helpful. It is helpful. But now the question is, will it replace the data scientist? Now we saw that it is helpful. Now we need to check, will it replace the data scientist or not? AutoML can also be help or can also help data scientists in data visualization, model intelligibility, and model deployment. Model data visualization means to convert object data into the visual representation data. Suppose pie chart I will take. Suppose bar graph I will take. Suppose linear graph I will take. This is the data visualization. AutoML frameworks help data scientists in data visualization also. Model intelligibility means it will select the model itself. The data scientist doesn't need to check which model is good and which model is not. Sir, I am from Hindi medium, but I want to join this course. Paras, if you can understand English, then it's okay. Are you able to understand what I'm trying to convey right now? Okay, your query we will discuss at the end. Don't worry, stay here. So in the model intelligibility, which means that it will select the model itself. Model development deployment means it will do all the steps. It will do training, it will do hyperparameter tuning, it will do evaluation, all of the things itself. AutoML is viewed as algorithm selection, means model selection, hyperparameter tuning of models, and model evaluation, as I just said. We can use less code here and avoid hyperparameter tuning. With the AutoML, we can use less code and avoid hyperparameter tuning. With the AutoML, we can use less code and avoid hyperparameter tuning. With the AutoML, we can use less code and avoid hyperparameter tuning. With the AutoML, We can use less number of code and we avoid hyperparameter tuning. What are the AutoML packages available right now? AutoML packages available right now are AutoSQLN, AutoVeka, and AutoKeras. So these are the AutoSQLN packages we have right now, by which we can do. Now we have a live example of AutoML, which is known as H2O Flow. What does H2O Flow mean? Suppose you hate coding. I will give you a simple example. Suppose you hate coding. You don't want to write any code, or you don't want to write multiple lines of code just to make a machine learning model. So then I will say you just go to the H2O Flow. H2O Flow is an AutoML, or I will say machine learning and AI platform. It is based on the AutoML science. Here we don't require to write any lines of code. We don't even require to write even single line of code. No. So how does it work? It works on just clicking, just a drag and drop option. Suppose I need to import files, I need to click here. I need to import SQL tables, I need to click here. I need to get models, I need to click here. I need to get grids, just click. I need to run model AutoML, I need to click. I need to import model, I need to click. I need to predict from model, I need to click on. Not a single line of code I need to write. This is the best example of AutoML right now. That is H2O Flow. It is a web application, means it works on a particular web browser. You can use Chrome, you can use Mozilla Firefox, you can use your Internet Explorer, anything. It's a web app. But here with this web app, if you want to deploy a machine learning algorithm, it is not necessary that you should know code. It is not necessary that you should know Python. It's not necessary that you should know R. No. You just need to click on these objects and this will do work for you without any hesitation. Okay. Now the question is, firstly, I'm going to ask you, any confusion still here? Any confusions regarding the H2O flow? Dilip, Ashish, Junaid Ahmed, Pankaj, Sagar, Sriram, Spandan, Tanvi. Yes, guys, any confusion till here regarding any topic? Great. I got the confirmation. So now the question, now the moment of truth, can AutoML replace data scientist? I can say that the AutoML it has been progressed a lot from previous years. When I started about learning this regarding the machine learning before 8 years, so that time the AutoML doesn't exist at all. Even though we used MATLAB for the data science top things. Means for any data science problem, we use MATLAB. MATLAB is a particular language which is used for the scientific computing. So MATLAB was popular that time for ML and DS data science operations. After that, R came into picture, and right now the Python, and it's irreplaceable now. But before, in between the R and Python, we saw the progress in AutoML. We can say that it has progressed a lot, but it doesn't have progressed that much that it will understand the business concepts. Business concept means, suppose you are receiving a data, and now you need to manually check the insights of the data. You need to check the emotions of that data. A machine can never do that. Suppose you are working with your father or with your any uncle and your brother about a business. You are working on a tire business, MRF tire business. You are working. You are inheriting at MRF tire business, and you know the company, you know the data, you know the logbooks, you know the how the transaction works. If your father is giving you the data and telling you to give me the insights about this data, will you be able to understand that data clearly or a machine? Definitely you, because you know the insights of that data. You know the insights of that data. Now you will tell me, sir, if I became the data scientist, sometimes I will receive the medical data, sometimes I will receive the industrial data, sometimes I will receive the different data. How can I judge different data when I don't have the knowledge for it? For that, we have domain engineers. Domain engineers firstly guide you through that particular company or that particular sector. Firstly, they will give you the proper introduction regarding that company, regarding their businesses, regarding their alliances, everything. Then they will let you decide how the data will work. This particular thing cannot be done without AutoML. AutoML will take this data as the normal data and it will progress it without asking any questions. Another thing, data gathering is the most important topic right now we have. Suppose if we want to predict something regarding the COVID, suppose I want to predict regarding the COVID, I need the data. I will get the data from three sources: WHO, Harvard, and USLI. So these are the three things from where I will get the data. But suppose I am relying on AutoML. AutoML will give one request to the WHO, Harvard, and USLI, and they will not give the data. Because in order to get the confidential data, a human intervention is necessary. I need to make WHO understand why I need the COVID data. What is my intuition? What I want to do? Will my research help them in progress something or not? Is my intentions pure? Then only they will give me the data. Then only Harvard will give me their data. Then only USLI will give me their data. They will not give me the data. I will just press the button and I will gather the data from the WHO or Harvard. No, definitely not. I need to make a series of conversation between them. I need to make them understand why I need this data. Then only I will receive the data. And while receiving the data, I can receive it in any format. I can receive the data from WHO, Harvard, and USLF in any format. It's not necessary. The format I needed, they will provide me in that format only. Suppose I need the data in the CSV format. I need the data in the CSV format. But WHO is providing me into the JSON format. Harvard is providing me into the SQL format. USLI is providing me into NoSQL format. I cannot complain to them, hey, no, I need the .csv format. No, I need to receive this data. Either this is JSON, either this is SQL, either this is non-SQL. And then I need to transform this. Then I need to model it. So can AutoML do this? No. He will not be able to do this. Firstly, he will not be able to develop the communication between these two resources. Then he will not be able to transform the data. So then I can say that this is the first point where I can say the AutoML fails in the data gathering phase only. So let's see another thing. AutoML won't supplicate data science discipline. If we see right now, computers are better mathematicians rather than normal mathematicians. But does that mean that we don't require mathematicians? No, we require even more mathematicians now. Why? Because in order to make a particular computer program, the most needed is mathematician. In order to make a particular software work, who is needed? A mathematician is needed. In order to make a scientific computing work, who is needed? A mathematician is needed again. So does that mean computer is doing right now the mathematical calculations and now we don't need mathematicians? No, definitely not. We need the mathematicians more than we used to need them. Why? So that they can govern, so that they can visualize, so that they can supervise whatever the computer is giving me the answers. The computer has calculated the distance between the black hole and to the from the black hole to the earth. Then only we could capture the image of the black hole. You might have seen it was very much interesting topic last year when we got the first picture of the black hole. But that doesn't mean that it was done by the computer. There was no hand of the mathematician who wrote that particular code, how to calculate that, who supervised that, who made changes in that. It was a mathematician only. Same is the case with the AutoML. AutoML is the thing. AutoML is the progressive thing right now. We can work with it definitely, but there needs a supervision, and it will not work without a data scientist supervision. AutoML has quickened their works. Whose work? Data scientists' work. Permit to them rapidly attempt things and help them to improve results. Definitely, they have helped them, but definitely it will not be able to replace them. Now, is AutoML close to strong AI? What does strong AI means? You people might have learned about the F-35 fighter jet. F-35 fighter jet is the most advanced fighter jet we have currently in this world, and it was produced by the US Army. This particular fighter jet has strong AI in it. Strong AI means which has the human kind of capabilities to some extent. To some extent, it will take the decisions same as humans are taking. This is the strong AI. But is AutoML having that same sense? Whatever human will take decisions, can it take the similar decisions? No. It is not that much of powerful currently. It cannot have human level insights. It cannot have environment level insights. So therefore, I cannot make it close to a strong AI. So therefore, definitely, if it doesn't have the strong AI, or if it doesn't have the human level insights, so definitely it will not be able to replace a particular person who is doing the job. We have the three solid reasons why current AutoML can never kill data scientist. So firstly, tell me, do you guys understood till here? Any confusions? Okay, good. Three solid reasons why current AutoML can never kill data scientist. Let's see the reason number first. Reason number first is that, as I already told you, data scientist is the series of processes. Data science is a series of processes. And in this series of processes, we have one process that is machine learning modeling. And then we have another series of processes. This particular process will be done by the AutoML for suppose. But what about these processes? These processes are still there. Who will do these processes? These processes are still be done by the machine data scientist. Machine learning model is a particular bullet point in these whole process lists. We have a list of processes. In this list of processes, we have one process as an ML model. This can be done by the AutoML, but rest of the processes, who will do it? Still, data scientists are required for these processes. The list of tasks that data scientists perform is quite long, in which machine learning is just a single bullet point. If we see here, AutoML software can only perform machine learning tasks. They are not yet eligible to carry out the whole data science process. So this is the first point. AutoML cannot work without a data scientist. As we just saw that they are not close to human level insights. So therefore, they cannot work without the supervision. Supervision may vary. It can be semi-supervised or fully supervised. But no supervision, it's not allowed at all. Whatever the results which I am getting from the AutoML, it should pass through a data scientist. Suppose this is the data and this is the AutoML and this is the result it's providing. This result will go through the data scientist. Then only it will go to the production. Means whatever results I will get from the AutoML, the firstly data scientist will evaluate it. Data scientist will evaluate it because without the evaluation of the AutoML results are total waste. Because we cannot believe on this insights. We cannot believe. We need to believe a person's insights who will evaluate it. So therefore, supervision is necessary. A result generated by AutoML software needs the validation of the pre-trained eye of the data scientist. Data scientists assure that either the results are correct and will make sense in the task or not. If the data scientist is telling that the results which are generated by the AutoML are false, we are going to stop that process at that particular time only. We are going to rely on a data scientist's assurance, not a machine's assurance. So this is the second topic. Now the third. Suppose I will give you an example. You are not a magician, but you are having a strong wand in your hand, magic wand. Will that magic wand will work? That magic wand will work, but that will not work properly. Ultimately, you will make some mistakes. But now, suppose you are a magician and you are a magician with a strong magic wand in your hand. You can make wonders with that. You can make a really good magic with that. So, so if a normal person uses AutoML, definitely that particular person plus AutoML, not good combination, but data scientist plus AutoML, very good combination. Because when a magician gets a magic wand, a powerful magic wand, he can do wonders with it. But if a normal person got the same magic wand, he doesn't know how to use that. So therefore, it will not work properly and he will end up doing some mistakes. If the data scientist doesn't carry out these tasks with accuracy, ML can never accomplish its purpose. So data scientist is necessary. So behind every successful AutoML, behind every success of AutoML, data scientist owns a huge round of applause. If a company is written that our model is dependent on AutoML, that doesn't mean that they are not using the data scientist. Behind that, there is a data scientist only who is making that work. I hope you understood. Any confusions, guys? So this is your answer. Now you can make your own conclusion. Will AI or will AutoML replace the data scientist or not? So I am questioning you right now. So here we have around 14 people are here, 13. So I am questioning you guys now after learning this much about this topic. So will AI or will AutoML kill the data scientist job or not? What is your answer? Okay. Okay, guys, I allowed everyone. Everyone can unmute themselves now. Now we begin our discussion. Any confusions? Please unmute yourself, or if you're not comfortable in unmuting yourself, just put your confusion on chat or your whatever queries you are having. Yes, Dilip. Yes, Dilip. Any confusions? Yes, Dasharati.
Okay, guys, I think, Miss, you don't have any questions. So thanks, Ajay. Thanks for a wonderful session. Ajay, can you give me the quick